BYJU'S exam prep and warm welcome to the monsoon series. So guys, who don't like monsoon? We all. We all like this monsoon series. So let us enjoy this monsoon series by learning the concepts and by preparing for this GATE exam. So guys, our BYJU'S exam prep has brought this monsoon series to strengthen your preparation for the GATE exam. So why late? Join the session quickly and mark your presence. I am Satya waiting for you all, inviting you all for this wonderful session. In this session, guys, we will be learning a very important concept, which is the very basic, fundamental pillar concept for many other concepts, like in data structures or in programming or in algorithms. That is how we can find the time complexity for the given code. So we have to follow or we have to learn what is the basic fundamental principle to find the time complexity. So today we are going to learn that. I request everybody, whoever have joined, please confirm, am I visible and audible to you clearly or not? Guys, please confirm my visibility and audibility so that we will start the session. So how we can find the time complexity of the given code. Let me start the session with a quick introduction of mine. I am Satya. I am a research scholar with 15 plus years of teaching experience. I have mentored more than 40,000 students all over India in the GATE and PSU categories. I teach programming data structures, operating systems, computer networks, computer organization and architecture, algorithms in our GATE syllabus. Myself qualified in GATE, UGC NET, SET and also certified by Cisco into networking and programming. So this is quick introduction about me. Astuti, IIT Bombay, when the document verification will start? Stuti, that we can't say. Please try to explore the IIT Bombay website on a regular basis. Definitely, they will keep the notification. Purnima, yes, you may, but you might need to stretch your deadlines. You might need to focus much because you may need to start from the scratch. You have to learn all the concepts and definitely you can do. Okay. All right. So guys, when we say time complexity, what is this time complexity is all about? See, it is the amount of time required by the algorithm to run to completion. When we want to solve any problem in the computer, we do coding. But coding will not come in a one step or automatically just like that. There is the very basic step for any program, that is algorithm. Means whatever you wanted to develop, first you will put in the general steps, simple steps. Those steps with the fine tuning, slowly you will turn that into pseudocode, and that pseudocode, if you apply the syntax of the programming language you want to apply, that becomes program. So any program will not be formed automatically. Okay, I understand you are not writing the algorithm for every program. You are a very good programmer. But guys, tell me, without thinking of the logic, do you start any program? No, right? That thought process, that ideology is what algorithm. Algorithm doesn't mean you have to put it on the paper. Even you think of how you can write this code, that thought process, that thought itself you can say as algorithm. Got it? So without algorithm there is no program. So for that algorithm, how much time is required to complete for the execution. That analysis of execution time of algorithm is what we say time complexity. How we can represent this time complexity? Like we have units for everything. Distance we represent in meters, kilometers. Weight we represent in kilograms, grams, right? Or speed we represent with meters per second, kilometers per second. Or some data we represent with bits, bytes, kilobytes, megabytes, blah, blah, blah. So there is a unit for every representation. So what is the representation for this? How you represent the time complexity? For that, we have got notations called asymptotic notations. These asymptotic notations, asymptotic term says the closest accuracy. Means we may not be representing the exact time in seconds or in minutes with this notation, but relative time means most closest time of this particular algorithm we will represent with this notation. And we know the mostly used notations are what? Omega notation, theta notation and big O notation. Omega notation we use to represent the best case time complexity. Theta notation we use to represent average case time complexity, and big O notation we use to represent worst case time complexity. Like on a small input, on a medium size input, on a big input, or in favorable conditions or unfavorable conditions. We can understand in different ways from different perspectives. If you want to represent the performance of any algorithm, with what notation you represent generally? Big O notation. Why? Because big O is the notation we use to represent worst case time complexity. Of course, in a worst case, if you understand what is the time this algorithm takes, means that is the maximum time algorithm can take. So if you are okay with that, then definitely that algorithm you can use, right? So the worst case time complexity generally we observe for analyzing the performance. Got it? Hi Shyam, good evening. Purnima, how much time? Chalo Purnima, time is not in terms of quantity, dear. In terms of quality, you have to think. Okay. Every day, if you can spend 4 to 6 hours of productive time from now, definitely by October or November, means in this 5 months time, you will be able to prepare at least 9 to 10 subjects and PYQ solving. Then in the December, you may go with little more practice and revision, and in the January, you can go for full length mock test, dear Purnima. Okay, but 4 to 6 hours is minimum, and remember that is a quality time, productive time, not just for the number sake. Productively, you have to spend that 4 to 6 hours time. Okay, month to month, you can increase it. All right. Okay, so in the algorithm, there are multiple steps. For each step, how much time is required, if we can understand, then sum of all those times, if we can do, then we will get an idea about the total time taken by the algorithm, isn't it? Now, what are different types of statements or expressions you find in an algorithm or algorithm turned into program? So in an algorithm or in a program, means in the given code, what kind of statements you will generally observe? We will see declaration or initialization or assignment statements. Means you may be creating some variables like this, int x, or you may initialize some value for this like x equals to 5, or after declaration somewhere you may be initializing some x is equal to y, you may be assigning some value to this, right? So either declaration or initialization or assignment statements we write, and computational statements, that may be arithmetic calculation or logical calculation or shift operation or bitwise operation or any other, something like x is equal to y left shift z plus I divided by j, something like this. Means you are doing some computation, the obtained result you are assigning to LHS. So this kind of statements we write computational statements. Hi Trivikram Prasad, right? And definitions means you can include macro definitions as well as function definitions. Means before main you may write some macros, or you may try to define some function. That statement you will see. And input output statements, maybe scanf, maybe getch, maybe getSkind or putchar, printf, puts kind of statements we will write. And some decision making statements also we use in our code regularly, like you may use if or if else, or you may use switch or else if else ladder, right? And looping statements, in the sense do while you may use, or while you may use, or for you may use, whatever. And recursive statements, suppose in a function f you may write upon certain condition f of x minus 1, f of x minus 1. This is a recursive statement. Guys, remember, if you want some statements to be executed repeatedly more than one time, we need not to write those statements multiple times, right? Maybe using control statement or maybe using recursion, you may make those statements to execute repeatedly. So through iteration, through recursion, we have two possible methods to make repetitive execution, right? So these are what different types of statements or expressions we will write in our program, isn't it? Any program you take, that may be matrix program, that may be some real-time application like you are writing program for distro algorithm, or you may be writing for Bellman-Ford algorithm or all pair shortest path, or you may be writing for 0-1 knapsack problem, or you may be writing for coin change problem, or you may be writing for the subset sum problem. Any problem starting from even or odd program to any bigger software application you take, these are what the statements possible we can write in the program, isn't it? Arun, Trivikram, Shyam, Purnima, Stuti, everybody, yes or no? Please respond. Are there any other kind of statements you see in code? No, right? Only these kind of statements we write. So if we can understand for what statement how much time is required to execute, that's it. Any code you can easily calculate the time complexity, right? So in the time complexity, there are certain kind of expressions or statements that it takes constant time. Constant time we represent as big O of 1, or you simply say big O of C. That may be 2, that may be 3, that may be 9, that may be 10, but any constant value we boil down and represent with big O of 1 generally. So what statements take constant time? See, declaration or initialization or assignment statements, they require constant time because they execute for one time. Always, if you write one time, they execute one time. Similarly, computational statement execute or take constant time. Definition statements, constant time. Input output statements, constant time. And decision making statements. In the sense here, I am telling not the code you write in the if or if else. Okay, please understand that. I am not talking about the time taken by the block. I am trying to tell you that to verify, suppose you are writing if x less than 5, you are writing some statements in the block. How much time required to verify this condition? That is constant time, right? I am not talking about the time taken to execute complete block of code. I am only trying to tell you that for if statement execution, else execution, switch to read that choice or option or switch input, that I am talking about. Got the point? So, when you write any of these statements in the program, you need not to worry about them because they take constant time. Okay, then how much time is needed to execute, perform iterative statements? For iterative statements, the time taken depends on how many number of times the loop runs, how many number of times or attempts loop execute. Because the loop may execute one time or n times or multiple times, right? So we have to take out that. So when you say loop, we will write just one loop in the program sometimes, or you may write multiple loops. Each loop is independent of the other. Means you are not writing one loop inside another loop. And nested loops means a loop inside another loop. A loop inside another loop. That is what we say nested loop. So how much time taken or required to execute these loops? That depends on how many times this loop execute, how many number of times this loop execute. Let us see some examples, dear friends. Suppose I write for I equal to 1, I less than n, I plus plus. Here I am just simply writing print I value. Suppose in the code there are all declaration statements, computational statements, etc., etc., but there is one loop. So how much time is taken by this code? Here, what statement or what piece of code is taking much time? So always remember, there are, suppose in a program, this is the program, in a program there are multiple statements. Statement 1, statement 2, so on, statement I. So there are multiple statements in the program. Each statement is taking its own time, let's say T1, T2, so on to Ti. So for the total program, what is the time we take? We say it as max of T1, T2, so on to Ti. So max of these times is the time complexity. Why I am taking the maximum? Because we are taking the worst case time complexity. So we will pick up the maximum time. But are these individual statements? No, right? We can't write, or we will not write all individual statements. Here, if I include this for loop, so this for block may take some time, right? So how many times this for executes? For I is equal to 1, 1 less than n true, the loop execute one time. When I is equal to 2, for 1 less than n, 2 less than n, 2 times. For I is equal to n minus 1, for 1 less than n, 2 less than n, so on to n minus 1 less than n, means n minus 1 time the loop executes. In the sense, this loop executes n minus 1 times. So the time complexity for this code, we first write it as big O of n minus 1, that is big O of n minus big O of 1. Here we can simply say it as big O of n, big O of n. Got it? Suppose I am writing some code for I equal to 1, I less than or equal to n, I is equal to I divided by 2. So how this I value is changing every time in the loop? First, I value is 1. Wait a minute. There is a small error here. It is not less than, greater than. Okay. Sorry. It should be less than, but here I have to change. I less than or equal to n. I is equal to I multiplied by 2. So here, how the code is changing the I value every time? Observe. First I is equal to 1. Loop, the statement printf execute one time. Then I change to 1 into 2, 2. Then I change to 2 into 2, 2 square. Then I changes to 2 cube. Then I changes to 2 power 4. So on until I value become 2 power k, that is less than or equal to n, it executes. That means the loop is executing k times, right? So until it is equal to or less than n, it is executing. So 2 power k less than or equal to n, that indicates what k is less than or equal to log n base 2. Loop is executing k times, means what is k value? Log n base 2. So this printf statement executes for log n times. Hence the time complexity of this loop we say as log n. Log n. Not only this, dear friends. Suppose I write the decrementing loop. Let's say for I is equal to n, I greater than or equal to 1. Suppose I am writing I is equal to I divided by some j. Okay. So printf I value. So first I value is n. Then n divided by j, I becomes. Then n divided by j square. Then n divided by j cube. So on n divided by j power k. Means again here also the loop is executing k times. Let us say until this n divided by j power k greater than or equal to 1, it is executing. That means I can say n greater than or equal to j power k. That means again k is equal to log n base j. So log n base j times it is executing. Hence, the time complexity of this code we say as big O of log n base j. So when the input is changing linearly, then the time complexity could be linear time complexity. But when the input is changing exponentially here, whether it is increasing exponentially or decreasing exponentially, then the time complexity would be logarithmic time complexity here you see. In this case, for these two examples, right? And we will write nested loops, dear friends, nested loops also we will write. For example, for I equal to 1 to n, for j is equal to 1 to n, some statement you have written. So for this kind of code, what would be the time complexity? Remember always, when you are writing nested loops, so the time complexity of nested loops, how do you calculate? That is equal to multiplication product of time complexities of each loop. Starting from inner loop to outer loop we write. So always find out how long this inner loop executes. This inner loop is executing n times. Inner loop is executing n times. 1 to n, and j is incrementing linearly by 1. Similarly, outer loop is also executing n times from 1 to n. So the time complexity would be big O of n into n, that we write as n square. Big O of n square. Guys, are you following it or not? Please let me know. Are you following it or not? Shyam, Arun, Trivikram, Purnima, and everyone. Right. Now, let me write one more nested loop. Let's say for I equal to 0 to n, I equal to I divided by 2. I equal to I multiplied by 2. For j 1 to n, j equal to j plus 1. For k n to 1 k plus plus. Some statement I am writing. So here 3 loops I have written. You may write any number of loops, nested loops. So how much time it is taking? What is the time complexity of this code that contains 3 loops, 3 nested loops? Always start counting the time taken by innermost code. What is the time taken by this innermost code, innermost loop? It is executing from n to 1, so it takes n times. This innermost loop executes n times, and this will execute n times. But the outermost loop executes log n times. So what is the total time complexity? It is big O of n multiplied by log n. So this we can write as n square log n. Got it? Similarly, suppose I am writing 2 independent loops, like for I equal to 1, I less than m, I plus plus. Okay, that is one loop. For j equal to 1, j less than n, j plus plus. This is another loop. Are these nested in nature? No, they are not nested loops. They are 2 independent loops. Now you take what? We have to take, suppose if you are having multiple independent loops. Then the time complexity would be sum of all the loops time complexity. So this loop run for m times. This loop run for n times. So what is the time complexity of this? Big O of m plus n. This is how you write. Because these are not nested in nature. These are not nested in nature. So basically, we have to understand that whenever there are iterative statements, we have to analyze each iterative statement individually, independently. Accordingly, we can say what is the time taken by this code. Understood? So, suppose I am writing one simple program, main values, whatever the variables I use, I am creating here. Okay. Suppose I write for I equal to 0 to n, sum is equal to sum plus I. Okay, this is one loop I have written. For I is equal to 0 till n I plus plus, for j is equal to 0 n j plus plus. Suppose I am printing, let's say, some array elements as a of ij. So this is the code I have written. Maybe this is the code to calculate sum of all the elements, all the row values. all the first element of every row sum I might need to calculate, and I would like to print all the 2D array elements. Means here I might take I, J, N, sum and some array. Of course, as I am using the scanf statement, I am giving the n value. Okay, understand, I have added necessary printf scanf statements. So what is the time taken by this code? See, this is the declaration initialization statements. They take constant time, and this loop run for n plus 1 times. I am talking about only first statement. First statement execute n plus 1 times. Why n plus 1 times? N times the condition is true. N times the condition is true, and that last time condition is false. But how we knew that the condition is false? Because we have verified it. That means that first statement is checked for n plus 1 times only, and the statement inside the for execute only n times, and this statement is executing n plus 1 times. Again the same reasoning. This statement executes n plus 1 times, but this statement executes only n times. Sorry, n into n times, because it is in the nested loop. And even this also will execute n plus 1 into n into n plus 1 times. So for each time the statement execution, let's say taking 1 second time. Okay, then how we write all the time taken by this? You can write it as 1 plus n plus 1 plus n plus n plus 1 plus n into n plus 1 plus n square. So you will get it as 1 plus 1, 2 plus 1, 3 plus 1, 2, 3, 3n plus n square plus n plus n square. So this you will get as something like 2n square plus 4n plus n, 4n plus 3. So if you apply this asymptotically, big O of 2n square plus 4n plus 3, you can write it as big O of 2n square plus big O of 4n plus big O of 3. So which is dominating here? Which is the dominating term? N square is the dominating term. So finally the time complexity of this code you will write as n square. So that is how I have taken. I told you maximum of the times taken. Maximum of the times taken by the blocks or the code statements we have to take as time complexity of the given code. Hope you all understood this point. Yes or no? Everybody please respond. You all got? So if some function is given, identify what kind of statements are there, what blocks are there, how much time taken by each statement or each block. Then first make it sum. Then finally you got some value. In that, find out what is the dominating term. That would be the time complexity of total code, because total program execution time is impacted by that dominating term, maybe n square or n power 4 or n cube, whatever. Understood? That's all about finding the time complexity of the given code. Tomorrow, dear friends, we will be discussing again another interesting topic, important topic 2, that is nested structures and unions, sharp tomorrow, that is Tuesday, sharp at 6 p.m. So guys, please do share this session link to your friends whoever are preparing for the GATE exam or any other competitive exams, because these classes we are conducting as per your request guys, because all these topics are chosen by you. We have taken a poll through Telegram. Accordingly, which topics got more demand, that topics only we are teaching in this monsoon series, right? So guys, keep attending all the classes regularly and get the most benefit of these monsoon series classes. Enjoy the monsoon and enjoy our classes. So our learning should not stop. So keep learning, keep growing, and please do like, share, and subscribe to our BEP YouTube channel and enable the notifications. See you tomorrow sharp at 6 p.m. Till then, have a great time. Take care. Good night, everyone. Bye bye. Thank you.